11.8, factor by grouping. Okay, factor by grouping, this is when we have four terms. And you refer back to your factoring sheets, this is the last set of factoring that we have. We did 3 terms guess and check, 2 terms with difference of squares, and now we have 4 terms, and this is our factor by grouping. First thing we're going to do with our 4 terms is always, still we are checking for a GCF. So looking through my terms here, I've got a coefficient of 1, 5, 3, and 15. No numbers in common. X to the third, x squared x, and no x's. And we have no GCF for this problem. So what we do with factor by grouping is we split this problem in half. The first thing I'm going to find is in common a GCF for only the first 2 terms. So between x cubed and negative 5x squared, these terms have x squared in common. Next, I'm actually going to factor it out of those 2 terms. So if I factor out an x squared from the first term, I'm left with x. And if I factor the x squared out of the second term, all I'm left with is minus 5. All right, moving on to the second set of terms, looking between 3x and negative 15. Between 3x and negative 15, we have a positive 3 in common between those 2 terms. Factoring it out of those 2 terms, I'm left with x minus 5. Now, we know we have successfully started factoring by grouping if the terms in parentheses are matching. Now, we've done this before when we did factoring GCF. Both of these terms now have an x minus 5 in common. So I'm going to factor that out. Once I factor out GCF of x minus 5 from both of these terms, all I have left is x squared plus 3 on both of those terms. I'm going to double check just to make sure that I've got nothing left in common between my 2 factors, and I don't. So this is fully factored. All right, so let's take a look at the second problem. Same process, I'm going to cut this in half. So looking at my first 2, I'm checking for the GCF. Between 2x cubed and x squared, I have an x squared in common. Factoring out from these 2 terms, I'm left with a 2 and an x. And if I factor out x squared completely from that term, I still have a minus 1 placeholder for when it multiplies back. My second 2 terms, looking between 10x and negative 5, I have a 5 in common between these. So positive 5, and that leaves 2x from the first term and a minus 1 placeholder from the second term. Here's how we know we're on the right track. We have matching factors in both of these terms now. Factoring that out as my GCF, I have 2x minus 1. And multiplying by what I have left over on both of those terms, if I factored out 2x minus 1, I have x squared and a positive 5 left over. And I have factored this completely. When I say factor completely, let's reread what it means to be factored completely. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So neither of these polynomials are factorable, so that means I'm completely factored on these solutions. All right, let's try another one out. Number 3. Problem is 8x cubed plus 2x squared minus 12x minus 3. Okay, the first thing we need to do is cut the problem in half. Looking at my first 2 terms between 8x cubed and 2x squared, my numbers have a 2 in common and an x squared in common. So this will leave behind on my first term 4x, leaving behind a positive 1 because I factored the whole 2x squared out. Now looking at my next two terms, notice here I've got a negative sign on the beginning part. So I'm going to start by factoring out this negative, and then between 12 and 3, I've got 3 in common. This would leave behind a positive 4x, and here with this negative 3, a positive 1. Notice once again, I have gotten these terms to match. That means you're on the right track. My last step is factoring out that 4x plus 1, and then writing the terms that are left over, 2x squared minus 3. Noticing that all of these are fully factored, so this is completely factored. All right, number 4. 15x cubed plus 12x squared plus 5x plus 4. Cut the problem in half, and let's start by factoring. Between 15x cubed and 12x squared, I have a common factor of 3 from the numbers and x squared from the coefficients. This would leave behind 5x on my first term plus 4 on my second term. When I look to see what's in common between these two terms, I cannot find anything in common. However, this is exactly what I want that parentheses to look like. So if it's already the correct factor, I still need a number out to factor this problem out. Well, I still know that two numbers always have 1 in common. So if I factor out a positive 1, this will not change the value of 5x plus 4. Therefore, these have once again matched, but now I do have my second polynomial. So my first one, factoring out what's in common, 5x plus 4 times what's ever left over, 3x squared and positive 1. You do need to factor out a positive 1 even if this is already set up as your common factor. That's what creates your second polynomial, and if we multiply this back together, it would multiply back to the original. Okay, number 5. Our problem is y squared plus y plus yx plus x. Two variables here works the same way with one. Cut the problem in half and find what's in common between the first two terms. Here I have y squared and y, so they each have a y in common. This will leave behind on the first term y, and on the second term a positive 1. Looking at these two terms, I've got yx and x. They both have a positive x in common, leaving behind y and a positive 1. Once again, these terms have successfully matched up, and that's my GCF. So I'm going to factor out a y plus 1, and left over from that is y plus x. This is fully factored, and we can always multiply these back together just to check. Y times y is y squared. 1 times y is 1y. Y times x is this xy. And 1 times x is x. All right, number 6. 12x cubed plus 60x squared plus 10x plus 50. Hopefully, when you were writing this problem down, you notice that each of these numbers had something in common. For this problem, they each have a number 2 in common. So always factor a GCF out in the beginning. So if I factor out my GCF of 2, I would be left with 6x cubed plus 30x squared plus 5x plus 10. Oops, not plus 10, plus 25. I apologize, let's fix that. Okay, now that I've factored out my GCF, I'm going to once again take my 4 terms here and split them in half. Don't forget about this GCF on the outside. That is still part of your answer. All right, looking between, I have 6x cubed and 30x squared. So between those 2 terms, I have 6x squared in common. This will leave behind x plus 5. Looking at these next 2 terms here, between 5x and 25, I have a positive 5 in common. This would leave behind x plus 5. Notice, once again, I've got my GCF between these 2 terms. So x plus 5, and what's left over is 6x squared plus 5. My last part here is my GCF of 2. This is fully factored. Okay, let's let you try a problem out on your own. Your problem is 5x cubed minus 15x squared minus x plus 3. Pause the video and try working this problem out. All right, I split this problem up in half, and I noticed between my first 2 terms, I had 5x squared in common. So I factored out 5x squared from the first terms, and I was left with x minus 3. My second term was very close to x minus 3, and they had no numbers in common. So very similar to example 4, I knew I had to only factor out a 1. But in order to get my signs to be exactly the same, I factored out a negative 1. Then I had x minus 3 on both of those terms. So my final answer was x minus 3 times 5x squared minus 1. Okay, that was kind of a tricky one. Let's do another one that you can try out. Your problem is x squared plus 8x minus xy minus 8y. Pause the video and try this one out. Okay, started by splitting my problem in half, and I notice here I had x in common between my first 2 terms. So I factored out an x out of my first 2 terms, and I was left with x plus 8. My second one, I noticed there was a negative sign out front. So I factored out a negative y, and I was left with x plus 8. These 2 terms matched up, which means those are my GCF. So my final answer was x plus 8 times x minus y. Okay, number 9, our problem is 4a squared minus 21b cubed plus 6ab minus 14ab squared. Okay, looking at this problem, if I'm splitting this in half, my first 2 terms here have nothing in common. 4 and 21 do not have numbers in common. A squared and b cubed, we have no variables in common. Sometimes this happens. If it's not in common, we must rearrange the formula, the equation, to make it factorable. So I'm going to just rearrange this a little bit, and I'm going to put my 21b cubed at the end because I can see here that these terms will have some b's in common. Keep rearranging until it kind of works itself out, but if I rearrange it like this, I now have 4a squared plus 6ab minus 14ab squared minus 21b cubed. Now I'm going to split my problem in half and factor out the common between 4a squared and 6ab. I notice between those two terms I have 2a in common, leaving behind on this one 2a and leaving behind on this one plus 3b. Alright, you finish this problem out, factor out what's in common between these two terms, and write your final answer. Okay, hopefully you factored this out. Noticing between negative 14ab squared and negative 21b cubed, this term was negative. So I factored out a negative, a 7 between these two terms, and a b squared. Once I factored out negative 7b squared, left over from that was 2a plus 3b. And now these have matched up. So I could factor this out to 2a minus 7b squared times 2a plus 3b. Notice once again, it doesn't matter which order you put these in. This time I factored my 2a plus 3b on this side. These factors can be on either side. Alright, our last problem for today, we have x cubed minus 6x squared minus 9x plus 54. Pause the video and try factoring this one out. Okay, factoring out the first term, I had x squared in common, leaving behind x minus 6. The second term I factored out a negative 9, and I was also left with x minus 6. So my factors are x minus 6 and x squared minus 9. But this isn't completely factored. X squared minus 9 is the difference of two squares. So this will factor one more time. The final answer in factored form is x minus 6 times x plus 3 times x minus 3. All right, ready for some practice the next day.